Dear students, today we discuss about direct broadcast satellite, also known as direct to home broadcast. So, why it's named as DTH, direct to home? In 1980s and 19 up to 1990s, the satellite signals, the, the TV signals are not received by directly from satellite. Actually, 1990s we are using Yahuda antenna to receive TV signal, which receive the signal from local retransmitting station. So Yahuda it's does not receive the signal from satellite directly from satellite. So these antenna which receive the signal from local retransmitting station, the retransmitting station which get the signal from the satellite, they get the TV signal from the satellite, they filter the noise, they amplify the signal, again retransmit to around 100 kilometers. The users are located in the in and around 100 kilometers, they can get the signal by using Yahuda antenna. After 2000, nowadays we are we are receiving the TV signal directly from the satellite. That's why it's named as direct to home. The signals are directly received by consumers. That's why it is named as direct to home. So 1970s, 1990s they use C-band. So all the users they need to buy large size of antenna. The C-band antenna diameter is around 3 meter. So entire receiver cost and antenna cost is more. So all the users they cannot buy individual setup box. That's why in 1980s, 1990s we are that time we are using Yagu antenna. It's a low cost receiver. After technology improved around 2000, the nowadays we are using Q band. It's another reason the frequency increases means the antenna size also get reduced. So the antenna size and the receiver cost also get reduced. Though all the users they get separate antenna and the setup box. So this is the general block diagram of broadcasting, TV broadcasting. So first block it's a TV station block diagram. Just the TV channels are transmitted to the satellite. The satellite it's a broadcast the signal to large area. So all the users in that region. So by using parabolic reflector and set-top box, they get the signal from the satellite. So this is the uplink diagram of TV station. The first, the analog audio video signals are converted to digital signal. So first we have ADC, the analog signal is converted to digital. So next we have encryption, MPEG-2 encoder. This encoder, not encryption, this is the compression method. In MPEG-2, it's one type of compression method which used in broadcasting application and DVDs, all those things. So it's a combination of audio and video compression standard. So next we have multiplexer. which multiplex all the channels, all other channels. So next we have read Solomon encoder and convolution encoder. So these two encoders for error detection and error correction. So at the receiver end, so we should recover the actual message. So we should reduce the error. So in the digital transmission, this is the main advantage. So at the receiver end, we can recover the actual message. So we should find out the error and we should recover the actual signal. So for this application, here we have read Solomon encoder and convolution encoder. So next we have QPSK modulator. So QPSK modulator or QAM modulator, any one type of digital modulators are used nowadays. Mostly they are using QAM modulator for TV broadcasting. Previously they used QPSK. Next we have IF amplifier. Next we go for up converter. The local frequency are converted into satellite carrier frequency. So for that, here we have up converter. So here the frequency is converted to 70 gigahertz. This is the uplink frequency. Next we have low power amplifier. Next high power amplifier. Next all the channels are combined by multiplexer. It's maybe any one of multiplexer TDMA or CDMA. Then it's transmitted through satellite in the frequency of 17 gigahertz. So this is the receiver setup box diagram. So in the downlink frequency, here we get 12.2 to 12.7 gigahertz. So in the outdoor unit, here we have parabolic filter with LNA. The LNA consists of low noise amplifier. Next band pass filter. Next we have mixer with local oscillator, which act as frequency down converter, which down convert the frequency from 12 gigahertz to 900 to 1400 megahertz in antenna itself. So here we are using low cost coaxial cable to feed a signal into indoor setup box. So yeah, suppose if not down convert the frequency means, so this low cost coaxial cable, through this low cost coaxial cable, if we transmit 12 gigahertz means which causes radiation loss. So to avoid radiation loss, the frequency is down converted in antenna itself. So that here we can use low cost coaxial cables. Otherwise we should use microstrip lines. So at the indoor setup box, first we have IF amplifier, next we have band pass filter, next mixer with local oscillator. Again, it's a down convert to IF 70 megahertz standard frequency. Next we have amplifier, next we have QPSK demodulator, next again baseband amplifier. So next we have decoders. Okay, at the transmitter we have encoder, read Solomon encoder and convolution encoder. So here we have decoders and MPEG to decoder. So at the transmitter just we compress the data. So here we have MPEG to decoder. So next we have digital to analog signal. So here we get analog audio and video signal. So it's feed to the TV. That's all.